Integration is our new topic that we are going to handle in this lesson. So let us see how we interpret functions and how do we evaluate functions. Now, to cover integration means that you have some knowledge about differentiation, because the idea of integration is the reverse of differentiation. Okay, as you are going to see, please don't forget to subscribe to the channel. Okay, start with now, let us describe what is integration. This is the process of obtaining functions from a function from its derivative. It's the converse of differentiation. Converse means we are reversing a differentiation. So if we differentiate a function, the value you get, to get back your original value, you integrate that function that you have got. The symbol indicating integration is this one, called elongated S, and it was selected as being the first letter of sum. In simple terms, integrating a function, we are summing it from certain value to certain point. Types of integrals. Let us see which types do we have. Definite integrals. Simply, these are integrals without limits. So simply, these are integrals without limits. When we differentiate, remember when we differentiate a function like x squared plus 3, we get 2x squared. And when we integrate 2x, we get x squared. We are going to see this. You increase this power by 1 by the power. Now, when you differentiate this, you get this. But when you integrate this, you get this. Now, you see that this 3 is not got. And you can clearly see that the constant 3 is not recovered. So we are not recovering. We are recovering the first term, but the 3 are not recovering it. So we always add a general constant c on the result so that it represents the constant lost. So when we integrate this, we always add a constant c to represent the other constant lost. Since called the undetermined, we don't know this one, that's why we call it a general. It's undetermined and sometimes commonly known as the constant of integration. Okay, so in simple terms, if I integrate this function so that we don't have limits, E is equal to f of x plus c. Now, this c is representing the lost constant we may have, the constant we may have lost over the way. Let us see indefinite integrals. Now, this c can be 0, can be 1, can be a fraction, so it's a real number, simply as that. So definite integrals. These are integrals with limits, and they are always evaluated to a definite value. Now, inside this one, these are what we call the limits. This is called the upper limit, and this is called the lower limit. So, assuming when you integrate f of x, this is small, and so we are getting that for f of x. I'm assuming that when you integrate this, you get this. Now, these ones, to evaluate that integral, in the function we have got after integrating, you substitute in the upper limit. Then after you subtract off, the value you get here, subtract off the value you get after when you substitute in the lower limit as this. So here, we have evaluated that integral. To evaluate definite integrals, we substitute in the upper limit in the result we have got, then we subtract it from off the result when we substitute in the lower limit. This is what it means. Then integrating or integration of x power n. Now assuming we have this function, to integrate x power n, we increase its power n by 1, and we divide it with a new power n plus 1. So we increase this by 1, so we are adding 1. So you say n plus 1. So the new power is this. Then this new power you get, you divide it with that function. As you see, if I have x power n, when I increase this power by 1, I get x plus 1. Then I divide it with that new power, this new power. Then I'm putting the constant of integration because you see I'm missing limits. Let us see properties of integrals. So, if we have always, you look at these functions, we always have this. This is always called our command function. This one is commanded to be, this one is always, whenever I see the x, it means that this function is in x, in terms of x. It's a function of x. Whenever I see the x, so this can change, it can be the t. When you see the t, it means that the function in terms of t. The theta in terms of theta. So, if we integrate in k, this is what we call a constant. The x, we just get this k, we increase it by 1 plus a constant. So, if we integrate in this, we start we are having a function with a constant. So, you can easily pull out that constant out, then you integrate this function alone. If you have two functions, when you integrate two functions, it's as easy as separating the two functions and then integrate them separately. Never forget this command here on those functions there. The same idea, if you are differentiating, you can separate them and integrate them. I mean, when you are getting the difference, you can also separate them like that. Note, if f of x is equal to x plus b, these are what we call linear functions. Why do we call them linear? Because the highest power on the variable is 1. So instead the x is having 1, so that's what they call a linear function. You know lines, mx plus c. The highest power on variables x and y is 1. That's why you call them linear functions. So if it's linear in this form, don't waste our time. You also integrate it by saying this is going to be 1 over a. It's integrated by saying ax plus b dx equal to 1 over a. The coefficient of this a, right? Then plus b, you increase the power by 1, divide by the new power, then plus the constant of integration. Then when we have this, and I'm assuming when you integrate this, you get this gx plus c. We add the constant of integration for the reason you know now. Then we integrate in a, b, u of x dx. Or is equal to this a over b, then we establish the upper limit. So, or is in simple terms here, we shall say that this one will be, by the way, a function and its derivative rare at later stages. But in simple terms, you get a coefficient of the variable, you get its reciprocal, then you increase the power by 1 by the power as we've seen in this lesson there. So that's it, members. Now we are going to see examples. I wish you well.